Hello explorers and welcome to another video. Today I'm gonna talk a little bit about the code generation in the Swagger tooling, or the Open API, which is the new name of the Swagger toolkit. So there is a way to generate code from a Swagger or Open API definition, and I'm gonna use my simple REST web server that I implemented in the previous episode. It was last week's episode, and you can find that by following the eye up in the right corner. If you want to watch that, it's not required for this video, but it's easier to follow along in this video if you know what we are trying to create in the end. So this Swagger generation toolkit has some things that enable a pretty easy extension of this toolkit. In Java you can create services, and these services could be called with a common API, and to enable one service you would need to create a file in metainf services and then the file name with the full package name, and in this file you just put the class or put a class that will implement this service. So in my case I put org.ea custom template codegen. So it's not a great name, but it's this is the name I chose. Another thing that will enable this is, if we look at my POM file here, I have actually some properties and SEM not important, and then I depend on the Swagger codegen CLI package, and that's because I want to actually create something that I can run from the command line, and to enable that I need to depend on the CLI library and then extend with my own service. And then I have a compiler plugin, so I get 1.8 sources and target. And this shade plugin here, this is a very interesting and important part. If we implement this and then add two specific transformers down here, we have a manifest transformer that will add the Swagger codegen class as a main class in my manifest, so it can actually run the application directly when we have built it. And I also add this service resource transformer, and that will actually take the service file and combine it with the other service file that comes from the CLI tooling. So we get a combined service file with my configuration and the configuration of the CLI tooling. And the CLI tooling has a lot of different generation targets, or languages as they call them, and this is just adding my own to that. And then we have a release plugin if we want to make a release of this tooling. Haven't done that yet, but I added it in this file just for completeness. So if we look at the specific template, then we have a lot of imports up here. It will extend the default codegen. This default codegen does a lot of the work, so we just need to implement a few specific targets, and the rest is done in the default generate code. It could be interesting to look in that code to get hints of what it does in different stages and so on. And this codegen uses a lot of different mustache templates to generate code in a specific manner. So it reads your Swagger file and then creates a data object structure that it sends to mustache template or multiple mustache templates, and these will generate your code for you. And this also implements the codegen config, and the codegen config is the actual service that we extend and will have different entry points that it will call during the generation process. In our constructor here we set an output folder if we don't specify one. We clear the model template files because I do not want to generate any models. In this case I just generate the API controllers, and the model files is something that you need to build your own, because I didn't want to actually have a strict implementation of those. I don't think that's a part of this server. I think that you should find your own implementation there, or whatever database you want to use, or whatever kind of data sources you want to use. So I would like to put that implementation off. And then I add some API template files, some API test template files, and doc template files. And these are the generators to generate all the controllers, the tests for the controllers, and the documentation for the controllers. And then I set a template dir, and this is the directory in my resource bundle that it has all the template files. And then we set some reserved words, and these are the reserved words for Java. I might have not remembered all of them. For instance, let could be removed here. It's never used in the Java language to my knowledge. I copied these from the JavaScript and then added some and removed some. And then we set some properties here. I set an API doc path, so I know where the documentation of the API is, a service port and an API version. So we have those values as well in our templates. Next up, we set the API package directory, and this directory is where all my controllers will be generated. So I just specified it here. Then I will specify what type of generator this is, and this is a server generator. I don't really know what this tagging actually does in the code, but I set it as a server because it is a server. And then I also supply the name, and this is the lookup it will do when I supply the flag L, -L, and then Java server. It will look through all the implementations in the service directory and find one that responds to the name of Java server. And then we have some help message here, so you can know what kind of tooling you are using if you run help. And here we have the API name, so this is what the different controllers will be called, and if the name of the controller isn't present, it will set default controller. I have not found a reasonable way that it actually should be any other way, but as it is today, we have this implementation. I think this is something that came from the earlier implementation. And this is also just an override to set the API name. Escape reserved words, also something that was here before and came with the default template. API file folder, so this is where the files in the API package will be. And the interesting thing here is that we actually replace all the dots with the separator char, so that's either / on Windows or / on Linux, so we actually get a path. And API file name just adds the API file name tag and adds the suffix, and the suffix is the other thing that is interesting, because we have a mustache file that is actually the implementation, and then we might want to write it as a Java file, or we might want to write it as an markdown file. So that's the suffix here. And then we have the test file folder, so that will be in the test directory, same structure as with the others. And the API doc file is in the API doc folder. And here we have all the definitions of supporting files. So these are mustache templates that are not specific controllers. Controllers will be generated from every different operation you have in your Swagger file, but these will be generated from the full Swagger file. So in this case, I generate an endpoint, request handler, and simple server. These we have seen before. I have a git ignore, I have some readme, a POM file, a license file, and a Swagger mustache. I get the YAML file for the full Swagger file out into my API doc folder. And next up we have get all the operations. This is just going through the Swagger data and picking out the operations. And this little sort operation by path, it's not actually doing that in my implementation. It's actually all sorting them and making them unique. So I just get one for each endpoint, I should say. And then I set the class name of that endpoint as the tag name, because when the Swagger template generation or the codegen is actually working, it looks at the tags for your different endpoints and then create a file for each tag. So in order to get my implementation of the simple server to work, I actually had to set a tag for each endpoint so it would generate that file for me. And that makes it interesting for me to actually say that the class name is that file. So in my request handler, I can actually make a listing of all the class files that is available. And I also set a path here, and that's the path of the specific endpoint. And then we have a preprocessor. It's a lot of code that was from the default template. Something I have added by here myself, this little code here. It actually goes through all the paths and gets all the operations with the method, and then fetches the tags. And then I go through all the tags and replace the path name with if it ends with an ID or with some something between brackets, so I know that it's an item path, then I will replace replace all of them with empty strings. So I will remove all of those, and then I will set item at the end. So if it has a bracket at the end, it's an item, and if it doesn't have a bracket at the end, so it just ends with the definition. So in my case we have /notes, and if it just ends at notes, it's a collection. But if it ends as /notes in brackets ID, for instance, and I know it's an item kind. So that's my different kinds of endpoints. It can either be an item endpoint or a collection endpoint. And then we have the actual operations. I created those down here. So I set an operation ID for each of the operations, and that's handle plus the method name uppercased. So in the case I get an operation, let's say get on the path of notes, then it will create a handle method that is handle get and put that in the file notes. And then down here I will create a string with all the tags and add just one tag. So for instance, if I have a path that is user /some ID /notes, it will actually take the first part and make that uppercase. So you get user uppercase, and then the first U is uppercase and the rest is lowercase, and it will append that string, and then we'll look at the next string, which is after the slash. So that was an ID that we removed earlier, so that's empty. It will throw that away, and then it will take notes with the first letter capitalized as well, and that's the actual tag it will create. So I know that it will actually create that file for me in the endpoints later on. And let's see here, we have the post supporting file data, and in this file you first off create the Swagger YAML tag, and that's used for the Swagger YAML file creation. So this has the full YAML definition and will be written there. And then we have all the operation paths here. So we had this little function up here that we sorted by path that actually got all the methods. So we got one method per one endpoint per method. So it will actually get a path list with all the endpoints and add each of them. So later on I can have operations by path. So I have an actual array that I can go through and generate my request handler. We will look at this later in the template, so it might be a bit clearer. And then we have some functions that were also from the earlier implementation. So let's look at some Mustache templates. I don't think it's so interesting to look at the endpoint. The only thing I've added here is the license info file at the top. The request handler here, we can see that I create something that goes through the API info. So that's the full Swagger file. And then I look at the operations path and go through that array. So I will loop through that and create an endpoint where I will put the path as the first argument, and then I will put the class name plus a repository. And this is something that is a choice I made, that I want to supply the repository to the class, and in this case I just supply an object repository to the specific implementation, the specific endpoint. And when you are implementing your repository, you just change this implementation here and add the repository to the specific endpoint. And the strength of actually adding the repository to the endpoint is that you can actually add a fake one when you are testing. So that's a little bit of flavor that I added to my template here. Then we can look at the actual API. Mustache, that will create each of the controllers. So these will be put in the package controllers. It's an endpoint, it has a specific class name, and then we create this little constructor up here with the class name, and then the repository that we put in the request handler. And then we will create for each operation in the operations something that has a specific operation ID as our function name. So that's the name that we actually looked at earlier. So handle get, for instance. And then we will create an implementation that just set response code to 500, endpoint not yet implemented. So it's actually an error that it's not implemented. And then we end our little Mustache loop here. If we look at the test, it's very similar. We also create something with a class name and add test after. We have our test repository. We will create an endpoint with the test repository as input. Then we will create a test with something that handles test handle and the HTTP method. So in this case it would be test handle get, for instance. And then we have a response string that we get from this endpoint when we call the specific operation ID. We will also fetch the response code. We'll check that the response code is 500 and that the endpoint's response is endpoint not implemented. And then we have a lot of other small files here. We can look at the POM. The only thing I added here was that POM will be generated by an artifact project name server. So it will actually get a specific naming scheme, and the output file will actually have the project name as a part of the file out. And in the README we also have some documentation here how to build the package, and we also put the project name in how to run the package. So we will do java jar target package project name and then server and this snapshot here. And if you do multiple versions, this version ID will change, of course. So that's pretty much what I wanted to show when it comes to the code. Shall we try to run this perhaps? See here. I did change the template, so back there. Let's see here. We do a package, so we will actually get the new code here. So now we build the tooling, and we got success there. We can run java jar target, and then we have this custom template 1.1 snapshot. And if we run this, we'll actually get a list of all the supplied available languages that we can use, and our Java server ends up at the top because it actually adds our file first and then appends the other files, the other file after it. So we can see that there's a lot of different languages that we can actually generate. So we run this command with generate, and then the language of Java server. We have an input file of Swagger YAML and an output directory, let's say test. So it will run through and actually generate a lot of files here. So if we look in our test directory up here, can close this, we see that we have generated a lot of files here. So in our API doc, we have some MD files for the nodes collection, node ID, and the user nodes collection. And in our test server, we have actually tests for all our endpoints. If we look at one of these tests, it will have the nodes item endpoint here. The test repository will be sent in, and then we see each of these tests here. So it will test each of the functions of the endpoint. And if we look at the server and look at item, we have this implementation here also, endpoint not implemented. So it's similar, and in the request handler, as we saw, it will have generated this little list here with the endpoints of nodes. We'll call the nodes collection, endpoints node/ID will call the nodes ID class, and then users ID nodes will call the users nodes collection. And as this actually imports all the controllers, it will find all of those classes. These structures might not be good if you have a lot of different endpoints. Then you will have a very crowded controllers directory. So we might want to do some other implementation then. So if we now have generated this in test, let's go into test and run maven clean package. Clean might not be required in this case, but here we build it. And if we look in the terminal window here, we see that we actually ran 2 tests for the collection, 1 test for the nodes item test, and we run 4 tests there, and then we run 1 test at the users nodes collection test. So all the tests passes. If we want, we can now go in and actually implement something. So if we go here, I will open up some different code here, so we can actually copy some code over. We will copy over the get request here. We will copy over the post. We copy the actual implementation of this nodes repository up here, and we add the these up here, and my earlier implementation actually used PA, so I will change those up a bit. We go into item and copy some code over there as well. And this code is all taken from the simple server project, so you can snatch that there. I actually copied the wrong code. This is the full code here, so this will be put up here. Check valid JSON, and then we have our little repository up here, and we will implement get, we will implement patch, we will implement delete with some code, and then I think put will actually just return handle patch with the request, so it will just run the same code there. So this is actually the implementation of the simple server. We need to go to the request handler and actually copy over the notes repository as well, so we can get an instance of that. And there, you can actually say that we want to use it here. Notes repository, so we don't call it object. So this should actually, we need to put an import there, so we import the actual file, and we also need the actual repository. So we create a new folder here, repositories, and we create a new file, notes repository, Java. We add the implementation of the repository, change the package there, see if this actually builds, and now I will run it with Maven test skip true, because we know that the test will fail because we haven't implemented any tests. And let's see here, we had a few errors here, and that's because I didn't copy over the actually notes repository into the endpoints here, so they actually know about it. That's an oversight. I wonder what item needed more to import. It needed to import the JSON object as well. Otherwise it won't work. Let's see if that will compile. It actually compiles. We can run Java jar target, and then take the notes server snapshot jar with dependencies and start that server. And now we will look at the notes client here. If we go to localhost and just go to notes, we see that we actually get some response back. If we update the client, we actually see some data here. We can actually do some operations here. Does it really work? And we reload, and we have the data saved here. So now we have, in a very short manner, generated some server code from a Swagger file. We have added some simple implementation to the server code and tested it. And we also, by using this specific tooling, we actually get pretty good documentation as well. So we can open a preview here. We see that we actually have an information about handle delete, handle get, handle patch and put. and I think we added some Java documentation that will be added to these files as well. So this is what I wanted to go through today. Now we have talked about how to generate an API from your Swagger template, how to implement the custom generator, and we have also seen how to run it, what it will generate, and also test run it, and how to test your specific endpoints. I hope that you learned something from this, that you found it interesting or fascinating. All the code for this generation project is up on my GitHub, so you can look into it more there. If you have any questions about the implementation, please feel free to send me a comment in the comment section. If you like this video, give it a like, share it with your friends and colleagues, and if you haven't done that yet, please subscribe to the channel, and I really hope to see you in the next video.